All right, strap yourselves in because today we're diving deep, right into the heart of our galaxy.
To the center.
Yeah, Sagittarius A, the supermassive black hole calling the Milky Way home.
That's right.
Our intel, hot off the presses, straight from the Space Telescope Science Institute, February 21st, 2025. And let me tell you, this research is shaking things up in astrophysics big time.
It is. You see, scientists have been using the James Webb Space Telescope, the
Webb?
Yeah, the Webb, to watch Sagittarius A in detail we've never seen before. And it's not what they were expecting.
What's got the scientists all riled up?
Well, they knew that Sagittarius A was active, right? They knew it would throw out these huge bursts of energy sometimes, flares.
Right.
But they didn't think it'd be a constant thing, a nonstop cosmic party.
Wait, hold on. You're telling me this black hole is constantly erupting?
Yeah, all the time.
Seriously?
Seriously, it's flaring and flickering constantly, without a break.
Wow.
And this variability is driving scientists crazy.
How so?
Well, some flares are super quick, gone in seconds.
Oh, wow.
And others are these massive eruptions that go on for days.
Really?
And then some shift gradually over months. It's this crazy light show, dazzling and perplexing,
I bet.
Makes it tough to figure out if there's a pattern to these outbursts, or if it's all random.
So if we could actually see this black hole, like with our own eyes, what would it look like? A giant blinking beacon in the sky.
That's funny you ask that. We can't see the black hole itself because light can't escape it, right?
Right.
But what we can see are the effects of its gravity and all that superheated gas and dust swirling around it.
Yeah, the accretion disk?
Exactly. That's where the flares erupt from.
So it's like trying to figure out a shadow puppet. Just from the shadow, you got to infer a lot from limited info.
That's a good way to put it.
But even with that limitation, scientists are coming out with some really interesting theories about what's causing those flares. Didn't you mention something about two main suspects?
I did. They think there are probably two different processes happening, causing both those short bursts and the longer flares.
All right, let's break them down. What about suspect number one?
Suspect number one is what we call turbulent plasma. Think of it like a fluorescent light bulb.
Okay.
Where electrical energy excites the gas and makes it glow, only this is on a much bigger scale.
Right.
And a lot more chaotic. So you have these little disturbances and turbulence in the accretion disk that cause the plasma, which that superheated electrically charged gas, to compress and release bursts of radiation.
Like solar flares, but on steroids.
Exactly, cranked up to 11.
Wow, cosmic fluorescent lights. I can't even imagine the energy.
It's huge.
What about those longer, more dramatic flares? What's causing those cosmic fireworks?
That's where suspect number two comes in. Magnetic reconnection. Imagine two huge magnets in space suddenly snapping together.
Oh, wow.
That's the kind of energy release we're talking about. When these magnetic fields collide, it's like a cosmic short circuit, releasing energy as incredibly fast particles.
And that creates those bright bursts of light.
Exactly.
That's some serious magnetic mayhem. But how are scientists actually watching this all go down? We're talking about a black hole surrounded by darkness. How are they seeing those flares?
Well, to crack this case, they needed a real super sleuth. And that's where the James Webb Space Telescope comes in.
Of course.
Remember, the Webb can see in infrared light.
Right.
Which means it can see through all that dust and gas that would normally block our view. It's like having X-ray vision into the heart of our galaxy.
So the Webb is giving us front row seats to this black hole's light show.
You got it.
Incredible.
And it gets even better. The Webb can actually see two different wavelengths of light at the same time.
Oh, wow.
And when they compared what they saw, they noticed something really interesting. The brightness changes at the shorter wavelength happen just a bit before the changes at the longer wavelength.
Wait, a time delay?
Yeah.
What does that mean?
That time delay, though small, is a big deal. It gives us clues about what's actually happening around the black hole. One leading theory is that particles lose energy faster at shorter wavelengths as they spiral around those intense magnetic field lines.
Okay.
And that energy loss could explain why we see the brightness change at the shorter wavelength first.
So we have the supermassive black hole throwing a constant tantrum of flares, and now we're talking about time delays and different wavelengths of light. This is getting pretty mind-bending.
It is, and we're just scratching the surface.
Well, I'm officially hooked. I need to know more. What are scientists hoping to find out next with the James Webb?
Well, one of their big goals is to observe Sagittarius A for a full 24 hours straight.
24 hours. Why?
A longer observation means less noise in the data, you see.
Like trying to listen to a whisper in a crowded room?
Exactly. The more you can filter out that background chatter, the clearer the message becomes. They're hoping this will give them an even sharper look at these cosmic fireworks.
And what are they hoping to see with this clearer view?
Two things, really. First, they're looking for patterns in the flares. If they can spot any repeating patterns, it could help them figure out what's driving these outbursts.
Right.
But there's also a chance these flares are truly random. And that would be pretty fascinating, too.
How so?
It would mean that even with all our technology and science, the heart of our galaxy still holds secrets we can't predict.
A truly unpredictable black hole, now that's a mystery I can get behind. But before we get too lost in the mystery, I think it's time to connect this back to us.
To Earth?
Yeah, why should anyone care about what's happening millions of light years away at the center of our galaxy?
That's a great question, and the answer is, in part, that this isn't just about black holes,
It's about something bigger.
Exactly. It's about understanding the universe we live in, the fundamental forces that shape it, and ultimately, our place within it. It's like we're putting together this massive puzzle, a cosmic one, and these flares are like tiny pieces.
So it's not just the fireworks themselves, it's what they can tell us about the bigger picture. What kind of secrets do you think those flares are hiding?
Well, one of the biggest questions is how black holes grow,
Yeah.
They think black holes start out as massive stars that collapse in on themselves.
Right.
But how do they go from, like, a star-sized black hole to a supermassive one like Sagittarius A? That leap is still kind of mysterious.
It's like going from a firecracker to a supernova. How do they beef up so much?
Well, the main theory is that they snack on the stuff around them,
Uh-huh.
like a cosmic vacuum cleaner, sucking in gas and dust from the accretion disk,
Right.
slowly but surely gaining mass over millions, even billions of years.
Okay, so it's a slow process, but I bet it's not always just a steady diet of cosmic dust, right? Things must get a little wild sometimes.
You're exactly right. Imagine what happens when entire galaxies collide.
Whoa.
It's a cosmic feeding frenzy.
Real.
Yeah, these collisions send shock waves through space, stirring up the gas and dust around black holes, and basically delivering this massive buffet right to their doorstep.
So it's like cosmic Thanksgiving dinner for the black hole.
Exactly. And I bet those feeding frenzies are marked by a whole lot of flare activity.
I bet they are. So studying these flares is crucial to understanding how these black holes grow and change.
Absolutely. They're like fingerprints at a crime scene, giving us clues about the black hole's past.
And maybe even hints about its future.
Right?
Okay, that's pretty cool. But I gotta admit, sometimes I get a little lost in all the cosmic jargon. Can you break it down for me and for anyone listening who might not be an astrophysicist? Why should we care what a black hole ate for dinner millions of years ago?
That's a fair point. It's easy to get lost in the details. But the truth is, studying these flares and how black holes evolve helps us answer some of the most basic questions about the universe itself.
Okay, like what? Give me the big picture stuff.
Well, for starters, by looking at the environment around supermassive black holes, we can learn about how galaxies form and evolve.
Right.
It's thought that these black holes play a huge role in shaping the structure of galaxies.
How so?
They influence the birth of new stars and even control the overall energy balance within a galaxy.
So it's like a cosmic ecosystem, and the black hole is the keystone species affecting everything around it.
Exactly. And then there's the even bigger picture, understanding the role of black holes in the evolution of the entire universe,
Right.
How did the universe become what it is today?
Yeah.
What's its ultimate fate? These are some of the biggest questions humans have ever asked. And believe it or not, studying black holes might help us find the answers.
Wow, I'm really feeling the weight of this research now. We're not just studying some random, far-off object. We're trying to understand reality itself.
Exactly. And who knows, maybe one day understanding black holes will help us create new technologies or solve problems here on Earth. A lot of the time when we explore the unknown, we end up discovering things we never could have imagined. Remember, the tech that gave us things like GPS and wireless communication came from our early attempts to explore space. Who knows what studying black holes might lead to in the future?
When you put it that way, it makes this whole thing even more exciting. But okay, let's zoom back in from the big picture for a sec. We talked about the flares and what they might tell us about black hole behavior, but what about the surrounding environment? What's it like in the galactic center? Is it just a big empty void with a black hole in the middle?
Oh, no, not at all. The galactic center is one of the most crowded and chaotic places in the whole Milky Way.
Really?
You've got dense clusters of stars, swirling clouds of gas and dust, intense magnetic fields, and of course that supermassive black hole holding it all together with its gravity. It's like a cosmic dance floor where physics gets pushed to its limits.
Okay, color me intrigued. Tell me more about what's going on in that cosmic mosh pit.
Well, for starters, you've got stars zipping around at crazy speeds, pulled by the black hole's gravity.
Uh-huh.
And then there are these massive gas bubbles that have been seen billowing out from the galactic center, like cosmic burps from a giant after a big meal.
The black hole burps. Okay, that's an image I won't soon forget. But seriously, what are those bubbles?
Scientists think these bubbles are the leftovers of powerful jets of energy that were shot out from the black hole millions of years ago. Imagine a cosmic fire hose blasting out particles at almost the speed of light.
Whoa.
Those jets slammed into the surrounding gas, creating shock waves that inflated these giant bubbles we see today.
Wow, a cosmic fire hose. And those bubbles, they're huge, right?
Oh yeah, we're talking tens of thousands of light years across. They
Wow.
dwarf our entire solar system.
That's mind-boggling. And then there are those filaments I've heard about. What are those cosmic streams holding the galaxy together?
They do look like cosmic strings, don't they? But we're still not totally sure what they are. Some scientists think they're connected to magnetic fields running through the gas and dust,
Def-
while others think they could be trails of particles accelerated by the black hole's spin.
So it's like a giant cosmic spider web with the black hole at the center and these filaments stretching out everywhere. But if we don't even know what they are, how can we learn anything from them?
Well, by studying these filaments, their shape, their composition, their movement, scientists can start to piece together clues about the forces at play in the galactic center. They're like cosmic barometers, giving us readings on the magnetic fields, the density of the gas, and the overall energy around the black hole.
I'm seeing a pattern here. Every seemingly random thing in the galactic center is actually a clue to something bigger, something we're trying to understand. It's like the ultimate cosmic detective story.
You got it. And that's why studying the galactic center, even though it's so far away and so extreme, is so important. It pushes the limits of what we know and makes us think about the universe in new ways.
Speaking of pushing limits, I have to ask about this rumor I've heard. Is there really another black hole out there in the galactic center, like a second one orbiting Sagittarius A?
Ah, yes, the elusive companions. It's a very intriguing possibility,
Is it?
and one that has astronomers excited. While we haven't definitively found a second black hole yet, there have been observations that hint at it.
Okay, spill the tea. What kind of hints?
Well, remember how we talked about the black hole's gravity influencing the stars around it?
Right.
If there's a second black hole, its gravity would create tiny wobbles in the orbits of those stars.
So it's like a cosmic dance, with the stars' movements revealing a hidden partner.
Precisely. And while these wobbles would be incredibly small, the James Webb Telescope is sensitive enough to maybe detect them.
Wow.
Right now, scientists are looking through the data, hoping to find that telltale wobble that would prove there's a second black hole.
A binary black hole system at the heart of our galaxy. That would be incredible. What would that mean for our understanding of, well, everything?
It would be a game changer for sure. It would open up a whole new set of questions about how binary black hole systems form, how they interact with their surroundings, and what role they might play in how galaxies evolve.
Okay, so we've got flares, gas bubbles, cosmic filaments, and maybe even a second black hole. The galactic center is sounding less like a quiet neighborhood and more like a cosmic circus.
That's a great way to put it. It's a place where the laws of physics are pushed to their limits, where the unimaginable becomes reality.
This deep dive has been a wild ride so far, and I'm already feeling like my understanding of the universe has expanded. But before we wrap things up, I want to bring it back to you, the listener. We've explored a lot in this deep dive: flares, black holes, even those cosmic burps. But before we sign off, I want to leave you with something to think about.
Yeah.
All this research, all these mind-blowing discoveries, what does it all mean for us down here on Earth?
That's a great question. I think there are a couple of ways to look at it. On a scientific level, studying the galactic center helps us refine our understanding of physics, how the universe works and changes.
Right.
It's like adding pieces to a giant jigsaw puzzle, a cosmic one.
Okay, so it feeds our scientific curiosity, but is there something deeper, something beyond just collecting data and refining theories?
I think so. I think there's a real sense of awe and wonder that comes from just thinking about the sheer scale and complexity of the universe. Realizing we're just this tiny part of something so vast and ancient can really change your perspective.
It's like a cosmic reality check. Our everyday problems suddenly seem pretty small.
Yeah, exactly. And then there's the inspiration you get from understanding the ingenuity and creativity of the scientists doing this work, pushing the boundaries of knowledge, exploring the unknown.
They're showing us what's possible when we ask big questions and look for answers beyond our own little world.
That's right. And I think there's a sense of connection, too, when you realize we're all made of the same stardust. The atoms in our bodies were created in the hearts of stars billions of years ago.
Wow, that's amazing. So we're not just connected to everything on Earth, but to the whole universe.
Yeah, exactly. We are literally children of the cosmos. And that could be both humbling and empowering.
You feel small, but also part of something much bigger.
That's it. And who knows what amazing discoveries are still out there.
Yeah.
As we keep exploring the galactic center with the James Webb and other incredible instruments, I have no doubt we'll find even more secrets and mysteries.
It's like we're standing at the edge of this vast, uncharted territory. The possibilities are endless.
Couldn't have said it better myself. The universe is a constant source of wonder, And the more we learn, the more we realize how much is still out there to discover.
That's a perfect note to end on, a reminder that the journey of discovery never really ends.
It doesn't. And who knows, maybe someday you'll be the one making those groundbreaking discoveries.
I don't know about that, but I'm definitely feeling inspired to keep learning and exploring. And to everyone listening, I encourage you to do the same. Keep looking up at the stars, keep asking questions, and never lose that sense of wonder.
Well said. Until next time, keep exploring the universe, both within and beyond yourselves.